Welcome to the DIY Honda Garage channel. DTC P2196 refers to an issue with the oxygen O2 sensor, specifically indicating that the O2 sensor signal is biased or stuck in a rich condition. This rich condition implies that there is too much fuel in the combustion chamber compared to air, affecting engine performance and emissions. The O2 sensor, also known as the air-fuel ratio (AF sensor, plays a critical role in measuring the oxygen levels in the exhaust gases, allowing the engine control module (ECM) or powertrain control module (PCM) to adjust the fuel mixture for optimal combustion. The AF sensor, sensor 1, is located in the exhaust manifold before the catalytic converter, while the secondary O2 sensor, sensor 2, is positioned further down the exhaust system, monitoring exhaust gases after they pass through the catalytic converter. If the adaptive offset of the AF sensor exceeds certain predetermined limits, the PCM detects an anomaly and triggers this diagnostic trouble code DTC. This troubleshooting guide aims to systematically address the P2196 error code to ensure proper vehicle function. The error code P2196 indicates that the oxygen O2 sensor signal is biased or stuck in a rich condition. This situation means the sensor is reporting an excessively high fuel concentration in the exhaust, which could compromise engine efficiency and emissions control. The AF sensor, sensor 1, is located upstream in the exhaust system, specifically before the catalytic converter, and is responsible for measuring the oxygen content in the exhaust gases. The powertrain control module, PCM, interprets this data to optimize fuel injection and air-fuel mixture. Additionally, should this sensor's adapted offset exceed a certain limit, it triggers the P2196 code, indicating that the sensor may be malfunctioning or that there are underlying issues within the fuel system or exhaust components. The PCM is crucial in managing vehicle emissions and fuel economy, which makes prompt diagnosis of this trouble code imperative for preserving vehicle health and legality. There are several possible causes for the P2196 code, each requiring careful examination. One common reason is a faulty A-F sensor, sensor 1. If this sensor is malfunctioning, it may provide incorrect readings to the PCM, resulting in a rich signal being interpreted. Exhaust system leaks are another potential cause. Any leaks present between the A-F sensor and the secondary O2 sensor can lead to erroneous readings, as the sensor may not accurately measure the oxygen content in the exhaust gases. Additionally, issues within the fuel system can contribute, such as fuel injector malfunctions that may cause an over-delivery of fuel. Other causes may include problems with the secondary O2 sensor itself, or faults within the PCM parameters that govern sensor function. Addressing these underlying issues is essential for resolving the P2196 code. The symptoms associated with the P2196 code can significantly affect vehicle performance and driver experience. One of the primary indicators is the illumination of the check engine light on the dashboard. This warning signifies that the PCM has detected a fault related to the O2 sensor, prompting the need for diagnostic actions. Drivers may also notice poor fuel economy, as an overly rich fuel condition can lead to excessive fuel consumption, reducing the vehicle's overall efficiency. Additionally, a rough engine idle may occur, characterized by unstable or uneven engine operation, which can be attributed to improper fuel-air mixtures caused by the faulty sensor detection. Recognizing these symptoms early can help in conducting a thorough investigation and timely repairs, ensuring optimal vehicle performance and compliance with emissions regulations. The first step in troubleshooting the P2196 code involves starting the engine and maintaining it at 3,000 RPM without load. This process allows the engine to reach an operating condition where it can effectively generate data for evaluation. By holding the engine at this speed, technicians facilitate a controlled environment where the PCM can self-monitor its parameters, including fuel mixture readings. After ensuring the conditions are stable, what happens? The technician should then observe the onboard diagnostic system, OBD status, through the Honda Diagnostic System, HDS, for the DTC P2196. This monitoring phase is crucial as it verifies whether the fault persists or resolves itself under these specific operational conditions. Should the code reappear, the technician must proceed with further diagnostic steps to isolate the underlying cause of the anomaly. The second troubleshooting step focuses on performing a thorough inspection of the exhaust system components. This stage is vital because any deficiencies in the exhaust can lead to erroneous readings from the AF sensor, triggering the P2196 code. The technician should meticulously check for any leaks in the exhaust system, particularly between the AF sensor, sensor 1, and the secondary O2 sensor, sensor 2. Leaks can significantly skew the sensor's readings, resulting in false signals to the PCM. Additionally, identifying any clogs or restrictions in the exhaust system is essential. These blockages can hinder the flow of exhaust gases, causing increased back pressure and affecting sensor performance. It is imperative that this step is executed methodically, as resolving any identified issues is a critical aspect of successful troubleshooting. In this step, the technician will install a known good AF sensor, sensor 1, to ascertain whether the original sensor was indeed faulty. This method is effective, especially since direct testing of the sensor might not yield conclusive results. After replacing the sensor, the technician will monitor the system to see if the DTC P2196 reappears. If the error code does not return, it indicates that the original AF sensor was defective and is now resolved with the new sensor in place. Conversely, if the DTC persists, it suggests other related components may be the source of the issue. This troubleshooting step is essential in confirming sensor functionality and establishing whether additional diagnostics on the fuel system or PCM may be required. The final step involves inspecting the secondary O2 sensor, sensor 2. This step is critical if prior inspections did not reveal any faults, suggesting that the secondary O2 sensor could be the cause of the P2196 code. The technician should systematically eliminate previous issues related to the exhaust system and the AF sensor to ensure a focused approach. If the previous inspections showed all components functioning normally, then it's essential to scrutinize the secondary O2 sensor for faults. This may involve testing the sensor's functionality and connections to the PCM. Finding an issue here would confirm the suspicion that the secondary O2 sensor is responsible for the DTC. Addressing this sensor can ensure accurate readings and restore overall exhaust system balance. After all repairs and component inspections have been completed, the final step is to perform a validation check to ensure the P2196 code is resolved. This involves rechecking the DTC status using the Honda Diagnostic System, HDS, to confirm that the code is no longer present in the system. A test drive of the vehicle is also essential to observe real-world performance, ensuring the repairs hold under varied conditions. During this test drive, monitoring the engine performance, emissions readings, and feel of the vehicle helps confirm that the sensor and associated systems are functioning as expected. Additionally, the technician should ensure that all relevant sensors are operational, and that the ECM optimally adjusts fuel delivery. This verification step is crucial for maintaining vehicle efficiency and regulatory compliance. Preventive maintenance is integral to avoiding future occurrences of the P2196 code. Regular checks of the oxygen sensors, particularly the AF sensor, sensor 1, can preemptively address any potential issues before they escalate. Scheduling periodic inspections of the exhaust system, including checking for leaks and clogs, is vital in maintaining the overall health of the emission system. Furthermore, monitoring fuel system components, such as fuel injectors and pumps, will ensure that they operate within their intended specifications. Routine maintenance can extend the life of these components and optimize engine efficiency, while also reducing the possibility of emission-related faults. Establishing a preventive maintenance schedule can significantly enhance vehicle reliability and performance. In conclusion, the P2196 diagnostic trouble code serves as a critical indicator of potential issues within the vehicle's oxygen sensing and fuel management systems. Through systematic troubleshooting steps, which include inspecting both the AF sensor and the secondary O2 sensor, we can effectively identify the source of the problem. Each component's functionality should be verified to ensure proper operation and eliminate false readings. Implementing preventive maintenance practices is essential for sustaining vehicle performance and avoiding similar problems in the future. By staying proactive with inspections and repairs, drivers can preserve both engine health and fuel efficiency, ultimately leading to a smoother driving experience and compliance with environmental regulations. Please like and subscribe to the channel. See you next time.